board here I have the properties of logarithms, and these are just basic properties of logarithms. I don't know what happened to this one here, but oh well. It got kind of squished up in a little bit. But the product property of logarithms says if we have the log of a product base anything, that it becomes the log of the first thing base the same thing plus the log of the second thing base the same thing. So if we have the ability to create an argument that is a product, we can split it apart into separate pieces. Okay. If we have a log of a quotient property, log of something divided by something base anything, it becomes the log of the top thing base whatever minus log of the bottom thing base whatever. So the base stays the same throughout these properties. The power property states that if we have log of a power expression base anything, the power can be pulled out in front of the logarithm, leaving us just with the base of that thing. And if m is equal to n, we could log both sides, base whatever, ln or log are usually our favorites because those are on our calculators, but you can go log base 17 if you really want to. I wouldn't, but you could. But again, as long as you have a true equation, if I have 7 equals 3 plus 4, that's true, then the natural log of 7 equals the natural log of 3 plus 4. There's no reason you'd want to do that for that specific problem, but you can allow it because that's what it says. And the other thing, going the other direction, if we have a log equal to a log same base, argument equals argument. So we have the ability to go either way. Basically what we're heading up towards is logarithmic equations, exponential equations, and these rules allow us to do a little bit of stuff with that. We're going to be dealing with these first three here today. These come into play the next couple of days of the lesson. So if we look at example 1, use the properties of logarithms that express the following logarithms in terms of logarithms of x, y, and z. Okay, the first thing I deal with when I'm doing laws of logarithms is these power and quotient properties. Then I deal with the power property afterwards. So I'll do the powers as is until I've got the terms separated into pieces, and then I deal with the powers second. So what I'm looking at here, is the argument every time. The base of the logarithm, again, is not relevant to the whole problem. It has to be written in the answer properly, but it doesn't matter what that base is as far as how you're going to do it. The argument there is a product, so I'm going to use the product property, which says that if I have log of a product, I can go log same base of the first thing plus log same base of the second thing. And what's being multiplied together there is x and y squared. If you want to get really picky about notation, if you put parentheses around those things, just to verify that you know that the squared is y squared, not the log squared. So putting those parentheses might be helpful. Then you can see here, it says to express them in terms of logarithms of x and y and z. Okay, there's no z, of course, in this one, but that's what we're looking for is expressions like that, log of x base 5. Nothing extra, okay? This is log of y squared, that's not log of y, so we don't want that. So this is fine, but it's going to be brought down since we're modifying the other one. So log of x base 5. And the rule here, once I get the product taken care of, is I have a power of 2, which is going to move out in front of the logarithm, so that's going to become 2, and then log of y base 5. Okay, so I've expressed that logarithm in terms of log of x, log of y. All right, and that is what they're looking for in this example, and the problems of that variety in the homework. All right. Use the product rule, quotient rule first, then pull the powers out second, and then circle your answer. All right. This one here, if you don't have powers written, okay, so obviously this is a quotient, okay, and again I want to deal with the power rule second, but keep in mind radicals are powers in disguise, they're fractional powers. So as I'm doing this modification, this is log base b of this stuff. The rule for quotient says I take the log same base of the top thing. Now the top is 2 square root of y. I'm going to write it as 2, all right, log of 2. Then I'm going to put plus log base b of y to the half power. Okay. The 2 and the square root of y are being multiplied together, so I'm writing that as a sum. It's being divided by z to the 5th, so I'm going to subtract log base b of z to the 5th power. So again, priority 1 is to break it apart into pieces. You don't want more than one object in each logarithm. So log of 2, log of y, log of z, right? Powers are going to be dealt with in a minute. All right? Then, At this point, and again, square root of y, right is y to the half power. If it's cube root, y to the 1/3 power. The fifth root of y seventh would be y to the 7/5 power, 7/5 power, so like that. And then what I'm going to do is, this is fine, I can't make that any prettier. This power and this power have to go out in front of their expression, so I'm going to get log of 2 base b plus 1/2 log of y base b minus 5 log of z base b. Okay, just because I know it's going to happen at some point, let me just show you one scenario for the quotient rule that you have to deal with. Suppose you get log, let's say base 2, of x over yz. Alright, so that's what our problem is. And we want to break that into just a simple logarithm of log of x, log of y, log of z. Alright? And what I'm seeing is y and z are being multiplied, x is dividing by y and z. Alright, so it's going to be log of x base 2, the top thing as is. I'm going to subtract log of y base 2. I'm going to also subtract log of z base 2. Because what I would really be subtracting would be the fact that it's actually log of y base 2 plus log of z base 2.
Yeah.
So I'm replacing this single logarithmic expression with a binomial. What I would do to the bottom, I have to do to every piece of the bottom so that minus distributes through. So if you have multiple pieces on the bottom, make sure that everything's subtracted on the bottom. When you get multiple pieces on top, you just get first thing plus second thing and so on. You start subtracting when you start dealing with the bottom stuff. So if you get multiple things on top, just subtract each piece. You can put this step in if you want. I usually avoid that step. I just go straight to the subtract each piece individually. And again, there's going to be purpose for that. Right now, the whole point of this is just to practice the skill. When we get to the point where we're going to be using this, practicing the skill will help you understand it better. And the problem's a lot easier to look at when we start actually using it for real. So practice it with these problems, but get good at it, understand the rules, know how to convert from some form to a different form. That's the main idea here. When we get to logarithmic equations, that'll come in very